Okay, so we're going to solve some quadratics, but first a little bit of a warm-up so you don't forget these. If you're solving this equation for y, and it's in both terms, you're going to need to factor y out. And then if you think about what's happening, you have y times that whole quantity 2x plus 3. So you're going to need to divide both sides of your equation by 2x plus 3. And you'll just end up with y equals 5 over 2x plus 3. So main topic for the day is some quadratic equations word problems. So picking out your information and figuring out your equation is kind of key here. Then you're going to just use your quadratic skills to solve. So we've got this triangular piece of land for sale. I know, so likely. They tell you a few things about it. So quick reminder, there's something in there about the hypotenuse. The only kind of triangles that have a hypotenuse are right triangles. Anything else, you just have sides. The hypotenuse only happens if it's a right triangle. So we do have a right triangle. So I've got my hypotenuse and two legs. There's one leg they tell us is longer and one leg that's shorter. So I'm going to label them here. Pictures always help me. We're supposed to find the lengths of the sides of the property. So information that we know. So one thing that we know is that the longer leg is 20 meters longer than twice the length of the shorter leg. So for my long and short legs, they've got this relationship where if I just label my shorter one x, the longer one is 20 meters more than twice that. So I could do 20 plus 2x for my longer leg. They also tell us that the hypotenuse is 10 meters longer than the length of the longer leg. So your longer leg was that 20 plus 2x that I just labeled. So the hypotenuse is 10 meters longer than that. So if I take my expression for my longer leg, 20 plus 2x, and add 10 to it, that would be the length of my hypotenuse, so 30 plus 2x. Now I need an equation that relates all this information. So anytime you're looking at a right triangle, don't forget the good old Pythagorean theorem. So Pythagorean theorem, if you've forgotten, says that if you take your legs squared and add them together, it equals the length of your hypotenuse squared. So we're going to plug in what we have for our expressions for our legs and our hypotenuse. So you got x squared plus 20 plus 2x squared equals your 2x plus 30 squared. And then it's just going to take some algebra and a solving. So if you square a few things here, remember if you're squaring something, you need to multiply it times itself. So I'm going to go ahead and write these out twice. It's going to be a little bit of algebra, but we're going to get there. So squaring your x is just x squared. If you multiply 2x plus 20 times itself, I'm going to jot my middle terms up above and then combine them together so I don't have to rewrite. I'm going to have 80x and 400. And then 4x squared plus 60x and 60x, so 120x. Plus 900. If you're doing a quadratic, unless you're completing the square, you probably want 0 on one side. So let's combine some like terms. Oh, actually, let's just go ahead and subtract 4x squared from both sides of our equation so that those 4x squareds subtract off to 0. And then if we go ahead and subtract 120x and 900, we'll have 0 on one side and we can go from there. You could factor this or you could use the quadratic formula. I'm going to try and factor it. X and x. One's plus, one's minus. And then things that multiply to 500. 50 and 10. There we go. Set each of your factors equal to 0. And you'll end up with x equals 50 and negative 10. So if you think about what x represents in our situation, though, x stands for the length of our shorter leg. So it can't be negative 10 because x is a side length. The only one that makes sense is x equals 50. So if you're supposed to answer the question, which asks for all the side lengths, don't forget to plug it back in. And besides 50 meters for your shorter leg, you're going to end up with 2 times 50 plus 20, gives you 120 meters for your longer leg, and then your hypotenuse is going to end up being 130 meters. Another situation where we're going to have to pick out some information and maybe draw a picture. We've got this ladder that's leaning against a building. So we're going to assume that the ground and the building are perpendicular to each other. There's my beautiful ladder. Things that we know. So they tell us that this is a 10-foot ladder that's leaning against the building. So let's go ahead and label that in our picture. So that's 10 feet for the hypotenuse of my right triangle. Other things, we know the point at which the ladder is hitting the side of the building is twice as high as the distance from the bottom of the ladder to the building. So if you look at the point where the ladder hits the building, that'd be up there. From there to the ground is twice as high as how far it is from the bottom of the ladder to the building. So we could label those x and 2x. Anytime we're talking right triangle, guess what? Pythagorean theorem. So we're going to set this one up. My cat's going crazy. I don't know if you heard that or not. So we're going to have x squared. If you square 2x, you'll have 4x squared. And squaring 10 gets you 100. So add those together. You get 5x squared equals 100. This one's a little bit easier to solve because we can solve it by taking a square root. So if you divide by 5 and then take the square root of both sides, you're going to end up with x equals positive and negative square root of 20. You can break down your square root of 20 into 2 square root 5. And then again, make sure that your result makes sense in the context of your problem. So x is a distance again, so you couldn't have negative value for your distance. So the distance from the bottom of ladder to the building is that 2 square root 5. One last one where they actually give you the equation, and we're supposed to use this equation to figure out if we throw this ball straight up, how long does it take it to return to the ground? So if you think about what's happening, your equation gives you the height after t seconds. So if I plug in like 1 second, it'll tell me how far off the ground my ball is. What I'm looking for is the amount of time t that it takes for the ball to get back to the ground. So when the ball is on the ground, my height is going to be 0 feet. So I'm going to take and plug in 0 for my height and then solve to see what number of seconds that height happens at. I'm going to solve by factoring, so I'm going to factor out a -8 here. And, nope, sorry, not a -8, just a -2. That's going to leave me with 8t minus 45. Set each of my factors equal to 0. And you'll end up with t equals 0, and if you add 45 and then divide by 8 over here, you're going to end up with 5.625 seconds. So you got 2 times because there are 2 points at which your height is 0 because it starts on the ground, and then it goes back up because you threw it in the air, and comes back down. So the one we're looking for is the 5.625 seconds that it takes to return to the ground. This one I'll let you try, but I'll give you a couple of hints if you get stuck. So they give you an equation for ticket sales, and you're supposed to use this model to find the number of tickets sold on the 30th day. So X in your equation stands for the day of ticket sales. So if you plug in X equals 30, that should give you the number of tickets sold on day 30. It's always important to know what your variables like stand for in your equation and what it gives you out. This one says on what day or days will 171 tickets be sold? So the equation gives you out the number of tickets sold. So if you put your output as 171 tickets and then solve it, you could figure out what day of ticket sales that would occur on. I forgot what my equation is, but you would set that equal and solve and be good to go. Good luck. Hope everything goes well.